All right, folks, we are recording. Good morning, good evening, good afternoon, folks, from wherever you're joining in. We'll allow the other folks to join in as and when they do. And my name is Prithvi Raj, the host for today's meetup, and I have been hosting Chaos Engineering meetups since the last 2 years, and I welcome you all once again. And thank you for joining in on a Thursday evening, afternoon, whatever it is for you. And this is on a trial basis. We usually organize our meetups on Saturdays, but happy to see you all joining in on a Thursday. And I hope that the next 1 hour is going to be an amazing 1 hour for you. And we are having 3 amazing folks with us who have been part of the community since long and who have been using Litmus for some time now. And before I introduce them, we'll just talk about what exactly we have on agenda with us, and then perhaps we'll move ahead introducing the speakers for you all. So as you know, the agenda, once again, chaos engineering hands-on, the practical experience of an SRE ideating chaos experiments, and the use of LitmusChaos. So obviously, in the last meetup, we saw how the folks, our friends at Accenture, build their capabilities to bring in the practice of chaos engineering. And then they decided to choose on a tool set, how they differentiated between the tools, and eventually ended up choosing Litmus. And now today we are just going to see an extension of the same, where they are going to share their experience on how they collaborated on various ideas and how they brought up this practice to their teams, and then eventually how they ran a game day and this became a capability at Accenture. And at the end, we'll also see a live demo performed by one of our speakers too. So without any further ado, just introducing the speakers quickly, we have Francesco, who's the Senior Manager of Site Reliability and AIOps Observability and Tech Lead at Accenture. We have Alexander, Senior Site Reliability Engineer and the Chaos Engineering Expert, once again at Accenture. And we have Jan Sagarna, who's also a Senior Site Reliability Engineer and Chaos Engineering Expert at Accenture. And obviously this session hopefully will help you understand the relevance of chaos engineering and building a proper base and foundation for chaos engineering. So without any further ado, I would allow the speakers to take the floor, and they can share the screen and move ahead with the meetup. And one more thing, for questions, we'll keep the question answer session in the end. And meanwhile, whoever is having any questions, they can put their questions on chat. So thank you so much once again, and the speakers, the floor is all yours.
Thank you very much, Prithvi. I guess you can see the screen, right?
Yes, we can see your screen.
Perfectly. Let me go next. Okay, just a small disclaimer about what we will say next and so on. And I will leave the word to Alexander Leo, that he will introduce himself. Alex?
Hello, thank you. My name is Alexander. I'm Site Reliability Engineer and Chaos Engineering Expert and Tech Team Lead with an experience of around 20 years in Ops, DevOps, and Dev. And hand over now to Jan.
Yes, thanks, Alex. So I'm an SRE and Chaos Engineering Expert at Accenture. The focus on my side is more to the technical part and programming from more industries and startups. Yeah, back to Francesco.
Thank you very much, guys. Yeah, as you can see, so I'm having a lot of experience, 20 years in SRE, in DevOps and DevSecOps. Nevertheless, also I gained a lot of experience in observability. I'm leading also the capability in EMEA. Let's kick it off directly with the agenda for today. So first of all, okay, the welcome, we already done. We go on next, just to recap what we saw last time. So we prepared just only one slide on the roadmap and where we are today and what you will see in the next couple of, let's say, 40 minutes. We will focus on how and the steps that we are doing usually to kind of create an experiment and to also put the experiment inside LitmusChaos. We will see also in what are the classical steps that we are executing when we are creating the experiment. And we have a live demo prepared. And last but not least, we have just a wrap up and the Q&A. I would jump in directly in the roadmap. I guess you recognize this roadmap was from last time. So the car like moved a bit. So now we are in the phase of, let's say we build our capability. Everything is there. We know how to use. We have the awareness call that we did with our teams, with the product teams and so on, and DevOps and SRE teams. And now we are in the phase of understanding what we will bring inside LitmusChaos. So what will be the experiment that we are going to create and why at the end. So the car moved, and you see is in the middle. Our target is start to create the experiment, understand how we are creating the experiment, create some of them, and we will show you how we are doing. We have as well like some template that we use, classical one, super easy to use and to start. And then it's the preparation of the game day. And this I will leave the word to Jan, that he will present the live demo and what we do usually in the game day. I will focus on how at the moment. Yeah, this one you know already from last time. This is our, let's say, chaos experiment life cycle. We will start with, I don't need to go like back on the complete slide as last time, but what usually we start is always with the whiteboarding. We try to understand what are at the end, the target identification. And we do also a session to try to understand where it makes sense. Usually we don't start here discussion about what will be the experiment. So what are the attack possible? We just to try to understand based on historical data where we can, where we have usually a blind spot at the end. They are just only like in high level, so usually we even don't go like so much deep, but I will leave the word later like to Alex that he will explain this step. The second one is about creating the experiment. Here is where we really shape the experiment. We try to understand what are the possible ones that we can execute. And we use usually like a demo environment. You will see also later with a microservice. And based on this microservice, we try to understand what we can do at the end. And then we have the one that you see here in feasibility study. This is really important. It's always, let's say, we are not giving so much weight, but it's important that we do a feasibility study. We try to understand if it really makes sense to execute this experiment that we design it. Also, like to try to understand what are the values that will bring. So are we just targeting the learning one, or do we are like bringing back some business, let's say, important milestone at the end, so improvement at the end. Then we have a dry run. Dry run is really the fact that we are running the experiment, and we try to understand, usually we don't even use maybe on production system, but we do in a smaller scale in pre-production on test, and we try to understand if there are complications at the end. If we need to add during the game day, maybe someone from the platform engineering or any kind of other department. This is really important step because it's similar to what we will execute later on the game day. And it's also where we define usually the stop button. I mean, stop button is really important because on the fact that when we leave this to run in a CI/CD pipeline, we don't have the overview of nobody, and it will happen when the pipeline will start, and can be automated during the day. So we don't know when it will start, and maybe can be even random. Game day, this is the fact is the biggest milestone where we show how to use actually the tool that we selected, and we will run the experiment. But also where we have the complete team together. It means that in this case, we are trying to understand at the end what are the results at the end, and the results of the experiment. I mean, can be everything good, can be also it can go wrong, and we need to stop and we need to press this stop button. It's really important that you define when you design actually the game day, who are the people that they will do the stop button. Should be the complete team, but usually someone that is having a look continuously also on the platform and infrastructure. As we said, we don't execute an experiment just only one layer, but we have a different layer. We identified that these are 4 building blocks, just to remember. So we have the application level, we have the platform level, the infrastructure, and then the rest of the team, I would say. It's really important that we take notes, and these notes that we will discuss during the reflection. Reflection, I think about it, is like what we use in Agile or in Scrum. Is really a retrospective. So there will be no blaming, and there will be it's completely blameless, and we are focusing on what we can bring next to the next level. But also because of this is a loop, so it will start again. We will improve maybe the whiteboarding, and as Alex will explain on the next slide, we are really covering the fact of try to understand how we can be effective already with the first experiment at the end. So let's go next then. Alex, I will leave you the word, and this is your first on what we are doing. You are still on mute, Alex.
Thank you, Francesco. Let's start with some whiteboarding target identification. To identify targets, we are using whiteboarding sessions. For such sessions, we are meeting with the main architects in a small round and discuss about the architecture in general on a really, really high level. We will dive deeper in and clarify all points until that point where all architects are even that will not be an issue, and it will work then. And for sure, there will be where we need more information from expert. That will be then clarified. The next expert will be invited to get here also set one in. Target of these sessions is to identify 3 points of interest. So what is a point of interest? A point of interest is every time when nobody is sure how the application reacts in this situation, or when the architects have different opinions on a scenario. Or another point could be 2 architects have a requirement for an interface and they have a different understanding of this requirement. And for sure, also last really important point is that if the architects are come to the conclusion that this should be checked in more detail, then you have also identified a point of interest. So typical architecture, Francesco, can we go to the next slide? Thank you. So typical architecture from the shop we will see later is looking like that one. That is also what you will have as starting point for a whiteboarding session. So yeah, depending on that graph, the architect can now discuss about each component herein. So what will happen in case that will crash, or what will happen in case of a network slowness, or what will happen in case of whatever. Also, you see here single point of failure inside, which is also a really important point to discuss about it. And also inside the whiteboarding session, we will clarify some main traps, which dev is typically not taking care about it because they have only a single instance and also only a single request. But for ops, it's really important to clarify it that we do not have here a resource which is used from different components at the same time. All right, that will now follow to a question mark. So for example, now if we dive here a little bit deeper in, we will have here the question for one of the service, what will happen if set pod is failing? And now the architect will do it in 3 different steps. So first one is user stories. So what is the impact for the user? Will he really recognize it? Won't he recognize it? How important is it? To get here also classification of it. The next one would be what will happen if one instance of this pod is failing. So typically we have multiple and the last one, the last step is we need to ask the right questions in front. So are we monitoring the right thing?
Okay, I guess Alex has some problem with the network. Well, but I can continue. The fact is that we are going to kind of place the right question, and what we wanted to discover is not only the fact of attacking one pod, because this is not in our interest. What is in the facts? Alex, you lost the connection. I was just continuing the last part.
Thank you. That was chaos engineering in production.
Yeah, I will just continue like on the example of the question. So on the fact that what we are answering is, are we monitoring the right metrics to investigate the problem? The fact that what we wanted to improve is that the SRE team, DevOps team, or any kind of team that are touched on actually solving the problem of this pod failing, they will have the right metrics and the right tool in place. The second question that we are going to answer, I mean, those are just an example. Is our platform able to auto-restore the service? Okay, so if we created the right scripts and the right maybe even configuration, you know, if you think about the deployment that we have in Kubernetes and you think about the replica or the horizontal pod scaler is where we are going to have this configuration. We are not kind of, let's say, removing the fact of having the right let's say, performance testing, but at the end, we are going to have an overview about what can happen in a failure condition. And then the last one is if we are placing just a question, is our team able to fix? Are they all having the same knowledge or understanding about the architecture or understanding about the scripts and so on, if we don't have a self-healing in place? If you have a self-healing, then it will be also the self-healing that will react somehow. And this is what we need to understand. Maybe I'll go on the next slide. I will leave to Jan. Jan, up to you.
Thank you, Francesco. So now we are on the next step. So we need to have, for this first experiment or scenario, we have defined 3 steps. So first, the draft of the hypothesis. For this, we created a hypothesis template to have a generic hypothesis. To use it everywhere, the same logic, everyone can re-understand it. So that's this example we have here. You can use for every use case. And Francesco, can you go to the next slide? And then we go next to the experiment selection. So you will see here, we have attack 1 and attack 2. So every attack has the same logic here. So we have the possible attacks, so pod, kill, and so on, and the target in front. And then we have the duration, so the duration of the experiment itself. Then the target in percentage, so you know when you do a network latency, you can define 50% of the pods or 100% of the pods. You will define it here also, that people be aware what is the target, and also the workload, so how many users are on the system. Yeah. Next slide, Francesco. And then we see here the first experiment or scenario. On the right side, we always put the architecture with marker of the attack. So in this case, we attack the product service. There you see the icon, and then we have the hypothesis here with this template we saw before, and also the attack or failure parameters with 2 steps. And then you also need to define the stop conditions and the revert conditions. There you have, in the most cases, a generic way. For example, we use Litmus, so we stop the experiment in Litmus directly. That is, in our case, now a stop condition. And the revert condition is that the system goes back to the normal state without any manual changes. Okay, next slide. Back to Alex.
Thank you. So now, after we have now defined an experiment, we come to the next step, which is a feasibility study. So we have now our hypothesis, which is now in our sample case here, that we want to kill the pods. And we want to have a high CPU load on set defined pods. And our hypothesis says also there should not be any impact for the user from our user story point of view due to auto self-healing and so on and so forth. So with the attack parameters we have now here, we defined now in our design state that we want to have it running over 10 minutes with a frequency of 5 seconds and 50% of the service we want to get down. And also for CPU, we want to have 100% of CPU load on it. And also we define stop conditions. So when we think we need to stop, for sure we need to stop when business is impacted. And we also have defined reverse conditions. So when the experiment is finished, what needs to be done to come back to normal state? So in that state now, we check it. Is it really what we want to do? Or do we want to change here something? Or maybe it sounds like a good idea, but in reality, it's not a good idea. For example, if we are checking now a virtual machine and we want to see what will happen if the virtual machine is down, maybe it's not the best option to just delete the complete virtual machine. Some may be much better options. And at least at this point, reflect it, think about it. Is it really what we want to do? And what is the best option? Or maybe there's a step in front we need to do just to check that everything is working fine and we can really do this first step. So far from feasibility study. As next one, we will have then the dry run phase. And during the dry run phase, for sure, we will execute all the experiments, not in the final state and not in the final scale. We'll do it only on a small amount when nothing will happen. But additionally to that, we will check the observability. So do we have the metrics in places? Are we catching the right things? And what is our steady state? And we will also check the architecture, the resilient architecture. Do we have any fault tolerance mechanism in place? Or do we need to prepare here something for the worst case scenario? We will also check the hypothesis and expectations. Again, the great question, do we have the right experiment? And do we have really an experiment? Or do we know that with that experiment, if we execute in that scale, we'll kill the system? We don't need to run anything if we know the outcome. It's not sensible. And for sure, alignment response, the next big point. So here we check if we have all documents for postmortem, for documentation, and so on and so forth in place. Also, we prepared every time a one slider, like that one we already shown for the experiment, just to showcase it. That is what we have done. And everybody knows it, what is really done, what are the defined parameters and the values for it. And last but not least, the reversibility. Is there a big stop button in place and is it working also? Also, do we have a revert plan? So if we need to hit the big stop button and abort the experimentation, will something bad things happen? Or do we have a plan already in place where we can check it? Do we have also right people here in place for reversibility? If we need, for example, an expert for a database, do we have him that we can really revert it? So from my experience, it's senseless to run an experiment if you cannot revert it. So for sure, you do not plan it, you do not want to have it, but be prepared that you need to revert it. All right, so far from dry run. Now, let's go ahead with the live demo as next. So, live demo, we have prepared, as already said, one page of what we want to do. Also with the hypothesis, here we are concentrating now to one pod in the demo application. And we will have here two steps which we have prepared. So the first one is a simple pod kill. It will run over 5 minutes with a frequency of 5 seconds, and we will raise down 50% of the services. So 50% of our pods. For sure, the other 50% are still in place. So we do not expect any impacts for our customers in that case. And a second one, we have here a high CPU load with 100% over 5 minutes. Also in that case, we do not expect here a real impact for the business, because here in the back end, Kubernetes will rehost and measure and do some activities against it. So it should not be a big problem. However, let's go here to the practice. Hand over now to you, Jan. Please start the demo.
Thank you, Alex. Yes, I will share my screen. So I hope everyone see my screen now.
Yes.
Perfect. Okay. So first of all, we saw the online shop before. So here's the online shop in a live demo. We can, for example, buy one item, add it to the cart, and place the order. And we will see now it's already loading a little bit longer, because we have already some load on it. And there we see the order is complete. And we have here the load generator. I will show it to you. So we have 150 users and a spawn rate of 20. And we started, and we have currently a value of 0%. And then we have also our Litmus. We have the cluster agent as a safe agent. You will see we will not apply the experiments like the over the UI. We prepared everything as an YAML file here as a workflow, and we will apply the workflow directly via the command line. Why we do this? Because it's easier and faster than click it by the UI every time. So we can do, for example, now the first step. Then we apply the one and then enter Litmus. And you see it's applied. Then we can go to our observability platform. In this case, we are using Splunk Observability. We see, first of all, our complete architecture, and we are taking currently the product catalog service.
Sorry to interrupt you, Jan, but can you just zoom your screen a little? A few users are asking to just zoom all the screen.
Yep. Let me reshare my browser. You see it now as only my browser. Is it better?
Yes, looks better.
Okay. So this is the dashboard for the product catalog service directly. We have the request of the latency, then the request rate, error rate. And we also can see we have other services which need the product catalog service, for example, front end and the cart service. And we also see the error rate is currently higher than 0. And when we go back, we also see here 12%, and it's going higher and higher. And now we can check. We also have this view where we directly checking the products to see the errors. So for now, we have here 0 errors. And let me open here what I do the most time. I open the pods to see if the experiment is still running, and it's starting. And now we see it's already starting here. We see the pod delete are running. And now we can check the monitoring, see what is happening. For example, here, I don't see any new data. Sometimes it's also a good sign when you don't see any data, then you have a problem with your observability platform, that the pods are offline and you don't get any data. So be aware of this. And we see now we get the data, and you see it's directly getting error rate for the product. And we also can check it on the UI, and we directly see, oops, we crashed the complete service and the online shop with only a pod delete. And we have it on a scale of 50%. Because why it's crashing, it's very easy because we can analyze it. We check the pods of the shop, and we see For the product catalog service, we only have one replica. And in this case, when you only have one replica, it's crashing 100% because it can only delete one pod. In this case, the complete online shop is crashing. But after the experiment is done, it should be coming up again and we can buy our favorite products.
Maybe Alex, so Jan, if you do one second, one pause, because there was a question on the chat. What is the objective of your pod delete experiment? Here, what we are going, maybe I will answer before this one and then go to the next one. On the fact that we discovered that with the pod delete, we are not just only deleting a pod at the end, but what we are trying to understand is the readiness. So how much time do we need to wait that this pod will be back? The second will be about the health check. If we place it the right health check, and what you see here in the dashboard, and Jan, if you can switch on the big picture, the connection they are made using gRPC, and we are using traces. So we can understand what are the dependency, and maybe Jan, if you go on the dependency one, we can also show what are the dependency and what we are impacting at the end with this pod delete. I mean, for this live demo, we should do something really, really easy. Last one that actually is the most complicated one is the bootstrap. The bootstrap that you need to have for this pod. How much time do you really need to wait when this pod is coming back? Sometimes the pod is doing other stuff, so bringing maybe like a sidecar or attaching to another service or doing a validation and so on. Here was it just only this small demo was based on this scope. So think about readiness, health check, and the bootstrap time at the end. And what are the SLI and SLO? If you want to go back on the workflow, so the last tab that you had on your browser, yeah, exactly. This is the workflow that we have. So if you see in the workflow, there is written front end, product, and any product ID. Actually, with the Splunk Observability is trying to catch all of these workflow. You will get the data. Of course, it's compiling and doing a calculation based on the average and based on the time window that we put of 5 minutes. Just only for this live demo at the end, okay? So usually in the real case or in a live, let's say for an SRE team, you don't have this, and maybe you will have like maybe an issue over a bit longer time. But what for the shortness of the demo and the shortness of this talk, we did wanted to give you here and wait 1 hour and having a real let's say steps and so on the chaos experiment. What is really important actually at the end is from SLI SLO perspective. I mean, in the workflow, they are similar to having this SLI. Now I can place any kind of technology or configuration to kind of alert the team if this error rate. I mean, you can recognize here we have all the golden senior, at least the three major one. We are not talking about the freshness of the data, but the number of requests and how many of these requests they will fail, and the duration, so latency, and of course, this is really important also on availability in general. And from a SLO perspective, we are not talking at the moment on a SLO perspective. Of course, we can add the alerting based on this, based even on anomaly detection. And your monitoring system usually should kind of recognize that there is kind of an anomaly because it's happening sudden of nothing. And the load is even normal because we are just only having 150 users. But if we think about to create a load of maybe 1 million of users, we are testing other conditions, and then maybe you have a better, let's say, configuration on SLO. An example can be testing when there is a high season where you have a lot of requests, and when there are maybe untypical requests, or you have a cyber attack and so on, you know, and you can have this test running, and the monitoring system reacting, alerting you, and making better the SLO or the SLA. Identify which SLA you need at the end. But what we see here, was pretty easy to identify this workflow. This is one of the critical user journey, as mentioned by Alex before, and is the one that we wanted to show you in this live demo. Of course, for a deep dive on our stuff, you can ping us. We can have a look on the specific cases at the end. I will answer a second question, then I will leave the word back to you, Jan. We have which experiment have you been using the most as of now? usually, to be honest, is the replatforming. So the node fail at the end, and really measuring on the fact how much time do you need to replatform somewhere else. Also considering that you have maybe a multi-cloud environment, and here is really critical to have a good monitoring. Otherwise, you don't catch absolutely nothing. And another one that we really use as a top 10, top 5, let's say, is on the latency. Latency can be not only on the pod communication between different services, microservices, because think about if you introduce this network latency, and you will see maybe in the next scenario, the fact that you are causing is also to have a blind spot on the in general on the observability tool, because you don't see nothing, and this will affect everything, and makes no sense to do if you already know that you will not have any backup at the end. And another part is so if we will introduce a latency of 2 seconds, the question is, are you seeing that you have this latency between the services? Yes or no? And this is the most complicated one. That's why we use also the latency pretty much at the end. And usually it's the one that are going to the direction of testing your golden signal. So if you have all in one dashboard, try to understand that. Okay. If you want, we have 20 minutes left. If you want, Jan, execute the next scenario. I will switch back on my screen, or if you.
Francesco?
Yeah.
There's one additional question in. So what would be the action item out of this experiment?
I can.
So I want to answer it here directly.
Yeah, Alex,
and,
you can.
Yeah, and that is quite easy. So we have now identified that 50%, if it's down, we have a single point of failure. That is it. So we need to increase here the scales. That would be the direct action item for it, because we have seen that the complete shop is now going down. And it shouldn't be. That is a direct action item. So that's all. Jan, hand over to you. Second scenario.
Perfect. Thank you. So like we saw, we had a directly impact, and now our on a job is back working. So for the next experiment, so scenario 1, step 2, we have, oh wait, I need to share my screen.
Yeah, thanks. Thanks, yeah.
Wait. Need to share this. Is it visible for everyone?
Yes, thanks.
Okay, so for the next one, we have the step 2, the CPU hog with 100% for 5 minutes, and we will directly start this. We already saw we now have an error rate of 0%. I will reset here the stats so we can see everything again from scratch. And now I will apply the second one. But I will reshare my screen so everyone can see the browser better. Give me 1 second. Like this. Is it visible for everyone now again?
Yes.
Yes, perfect. Then I will start now the second one again via the command line. And now we can go to our product catalog service, and we have here our pod metrics, and we already see with this pod crash, we have a fancy graph here because it's going up and down because of the Litmus is trying to crash our pod, and GCP trying to start the pod, and that's why we have the spikes here, and we will see the same again now. Now it's starting. We see it's going first down. And now we have again spikes. You also can take a look of the host usage. Should be also going up.
Maybe in the meantime, Jan, I will answer two questions in the chat. Before starting Litmus, did you test the other chaos tool? Yes, you can check as Prithvi sent you, Diego, the video from the last event, and we had also kind of shortlisted, and we had a scorecard that we were running, and then you can see there that we figure out what was important for us, depending by the at the end depending by the use cases that we had. The second is which feature were important. Yeah, you have there anyway also the feature that we wanted to have. Then we have you combined more than one experiment as a workflow? Yes, we have. Depending, so usually if you also watch the last video we mentioned it, please try to keep in the beginning, if your first, if it's your really first experiment, to keep only one experiment and one step per time, as Jan also did now, because we want to keep the blast radius as small as possible. Blast radius means that you are not impacting the whole functionality. I mean, you figure out with this small man, with this intentionally. We know that it's only one replica, but imagine if we had 3 replica, would have happened almost nothing. So some users that will get killed, someone that were landing in this pod that was failing, but at the end was just a retry at the end. And if we are going to concatenate from the beginning, we will increase this blast radius, and then you have completely down, let's say, the whole functionality. Or as I said before, so we are talking about readiness. We are talking about the emptiness of the pod where we are killing. If I'm going to add also the CPU hog, we will just add on top another problem, and it will only amplify the magnitude of the incident that you already have. At the end, maybe that in some reason, like an example is making only partially unavailable, not completely available. And think about if I have a 3 replica and I'm going to target maybe 80% or 70% of the deployment. Then in this case, if I add the CPU hog and then add also a network latency, what I wanted to test is the fact that Kubernetes will try to, or your ingress controller will try to load balance between the different environment. What we discovered is that sometimes the load balancer is not reacting immediately because maybe of a configuration, and the traffic actually will not go to the pod that is not failed. So this is one part, and you will measure also how much time do you really need to have a complete switch. What we figure out on the other side, when we add the network latency and maybe even the pod kill on services that actually they are talking with the external. Yeah, thanks, Jan. So payment service, for example, is talking with the backup payment that actually is a third party. As you see, there is around of this of the services that are the point that are dotted. It means that it's not under our control, but we want to try to understand if this one will fail, if we have an impact also on the payment service. Actually, we have an impact. This microservice is really made to have this kind of experiment if you are starting from scratch, from zero. And when you are going to have this experiment on payment service, you try to understand what will happen when the third party will go down. Are there someone reacting? Do we know that the procedure is there? And even more, if we need to add some other control and checks on the dashboard at the end. And the fact of the CPU is, in principle, is to try to understand also if your horizontal pod scaler is reacting on the right time, but also if your monitoring tool is understand that there is a problem at the end. And by the traces, usually you get also the feeling of having this problem, and you can also deep dive and try to understand which especially traces were caused by your expert at the end, and also to document what you can do. Another problem that we find maybe in the network latency as kind of the experiment that we are mostly using is the problem of the pool configuration. So if I have a connection from a microservice to a database, and maybe you forgot to add the configuration of different. Yeah, thanks, Jan. You are showing the error rate. If you have this configuration and you forgot maybe to add the pool or a DNS, and you have a network lesson inside caused by any kind of condition, maybe like a normal problem inside the pod, then you are testing even the connection with database and so on. And we have 10 minutes left again. I would go maybe like, if it's okay for you, in the wrap up, and we leave space for extra question, I would say.
Sure.
Let me share my screen. Okay, so what's that one? Let me share again. Okay, the most important, as we saw also like from your question, is really interesting. The first like tips that we want to give to you is that you need to plan again. So don't do really random stuff in the beginning, but try to understand which one they are making sense, and avoid to execute the chaos experiment unprepared, because it will cause just a problem, and at the end makes no sense at the end. I mean, this is the clear one. On the planning phase, there is this structure. I mean, you can get this loop. You can get also the experiment that Alex was explaining, and Jan with the template. Templates, they are usually used to really like give you like an idea what you need to do in the beginning. And think about that the chaos experiment should always start that we believe. And we are trying to kind of, let's say, experiment on our belief. We believe that everything will be good, everything will be fine, and everything will hold and true. But then after you are going to do the experiment and trying to understand, you can even always put like a belief on like the monitoring tool or on the SLO that you place that are really perfect, and you will catch everything before of the end user and so on. But when you do the experiment, we run the experiment, and you do the game day, and you do even the reflection later, you will try to understand if this is the correct one. The second most important one is to visualize the critical user journey. I mean, you saw, thanks to Jan before on showing on this Splunk dashboard, you saw in the workflow, and every workflow, we don't have only this one. This was the top one, because if you saw like from our, let's say, I mean, performance testing or even synthetic tool. So we use Locust, but we use other tools. So this is just an example. We kind of are trying to simulate a normal user. A normal user will go on the front end, will maybe check the product catalog, will click on some product, will add on the cart, and then buy at the end. So this is there is nothing like so complicated. But what you see here is the critical user one. So if I don't see like my catalog, I cannot click on adding it. And what's the easy one? If we would have just crashed the front end, or we would have just crashed another service, I mean, you already know what will happen. So front end, you cannot enter, then everything will be down. So it's not bringing to you nothing. So, and here in the user journey is the one that we are going to have our focus for the experiment planning, but also whiteboarding and execution. SLI, SLO, so as someone mentioned in the chat, yes, try to visualize them, put on paper, try to understand what you want to achieve. Do you want to improve 5%, 10%? How you are going to improve it at the end? At the end, the SLI is one of the workflow that you saw. You can get one of them that was there, so latency, error rate, and so on, and visualize them and what you want to achieve. If you are going down, then the goal that you set, then automatically you have the problem. You can even use the error budget at the end. So causing one of the failure, like a pod kill or CPU or a network, you can try to understand how much error budget you are burning and how fast you are burning. This is also part of the chaos experimentation. So everything related to SRE will be really good for you at the end. Then we have the last two. So do not forget the big stop button. Who will be the one that is saying, hey, we need to stop because we will not recover. There is a special number that is the time that you, let's say, there is a specific point that you will never recover, and maybe you will recover really maybe in 1 or 2 days and so on. And if you have already in mind that time, and this is the recovery point, try to always keep in mind when you are doing an experiment. So if I concatenate a 3-4 experiment and then I cannot stop like on time, then you will pass this time. So if your time is 1 hour, is 2 hours, and then you have a problem, also based on your budget, if you're running on production system, this needs to be your stop button in the end. Stopping, and you need to have a completely plan, the reverse plan, really written, also put maybe in the experiment, that is telling to you what actually you want to what you want to achieve at the end. And the last one, spread the voice and share the winning use cases. This is really important. Prepare a slide, make a huge win, and even if you achieve it, maybe increasing or improving 2% of your SLO or 2% of better of discovering blind spot and so on, make this visible. It's really important that you share this, because only if you are doing this, then there will be other people motivated on at the end on using the tool, but using also chaos engineering in general for other use cases. And don't forget, start small and scale fast. I will leave the word. We have 4 minutes left. We are on time today, briefly. And I will leave for Q&A if you are still having some question. Yeah, for the observability tool, yes, we tried other tool. What we find at the moment, and that is kind of giving to us the most benefit is the Splunk observability. On the fact that we don't need to deploy any sidecar, so we are not making heavier our deployment, and there is a special collateral. I mean, you can read on the documentation. And the fact that we can scrape any kind of metrics, just only the ones that are there, even with underlining public cloud provider. In this case, Jan was using Google, and we can get metrics also from Google. He showed it before, this view of having different, let's say, like metrics on the same page. So we start from application level with the whole actually, I mean, the golden signal from the application, and it could like jump on the host metrics and on the pod metrics, that you have like a vertical in one page. We didn't got this with other tool, and at the moment is the one that we use at the end. At the moment, we are using as self-served. We are not using the one that is online, and even for the game day, we use our hosted, just only because of we started like this at the end. And our target in the future is to have anyway the continuous verification, where we have, of course, chaos experiment implemented directly in CI/CD pipeline. We are using different tool, and as also showed before by Jan, we had an experiment running in Argo CD at the end. That is the default at the end. Okay, there is still another question. In case of complex system, there could be many experiments in such situations as a priority. Yes, exactly. That's why usually if you use only one experimentation, let's say platform, use only one, where you see already if there are other, let's say, experiment already running, and that you get an alert. In Splunk observability, you have also the possibility to correlate a kind of different, let's say, outages and so on. And what we did is we scrape also the metrics coming from the LitmusChaos, and we get a dashboard specialized only for us. I mean, we don't give all access, because otherwise you will remove the good part of having this running for the different teams. So not all of them they have access, but usually the chaos engineering capability has access and can understand if there is already one other let's say another experiment running. If they are running in a different namespaces and they are not connected, that's not a problem, because of course you should have this case at the end. We have 1 minute left. Prithvi, I will leave it to you.
Thanks a lot, Francisco. I think that was an amazing meetup, and thank you so much, everyone, for joining in. It was great having you folks once again, and I think the questions were great as well. And the recording will be up on the YouTube channel by next week. I just shared the link to the YouTube channel so you can subscribe the same and get access to the recording. I think we are on time, and thank you once again for keeping up for an hour on a Thursday afternoon, evening for you all. And thank you, Francesco, Alex, and Jan once again for an amazing meetup. And it was great to learn how you started your journey and you culminated it with a live demo on Litmus. So thank you once again, Alex, Jan, and Francisco. And thank you once again, everyone, for joining in. And once again, we'll see you all in the August Chaos Engineering meetup. Until then, embrace the Chaos Engineering movement. Happy Thursday and a happy weekend, folks. Thank you. Thank you once again.
Thank you very much. Thank you again, Alex and Jan. Bye.
Thank you. Bye.
Thank you. Bye-bye.